Good morning. On behalf of the school, the university, and our business analytics program, I welcome everybody who is here today, the alumni, our students, and all others who are present to be part of this session. We have a wonderful panel who are going to talk about artificial intelligence. And I'm sure you want to know if it's real or hype, and they're going to help us sort it out. To give them the most time so they can share their ideas, I wanted to know a couple of things. First, this panel is composed of companies which have partnership relationships with Weatherhead and the university. And they work with us to make our programs better, our students better trained, and to bring the real-world practice into the classroom. We think that's very important for us, and they help us do that, so we thank them for their partnership with us. The second, I asked them to develop a presentation that'll have the recent ideas as well as interesting ideas that can be good, useful for both the people who are wanting to learn more about the field and those who just want to know what's going on. So it has components of both. To make it effective, we'll give them 15 minutes each to make a presentation. And I'm going to have 5 minutes for any QA which is directed to them alone. These could be clarifying questions or things that you want to be expanding a little bit more to understand their ideas. And then towards the end, we'll have 20 minutes for a broad Q&A. So these questions could be integrative, could be directed to any one of them, or anything else you want to discuss about artificial intelligence. And I would like you to use the Q&A to explore whatever is on your mind on AI. So with that, I want to begin with each one of them, beginning with Brian Martin to my left. And they will introduce a little bit about where their journey is. I really wanted to see how they came into this field, what excites them, and what makes them interesting for them. So with that, Brian Martin, please come on. Let's give them a hand.
Squeeze my way through that little gap there. Good morning. I'll still call it morning. It's closing on a little bit later in the day, but we're going to talk about whether AI is real or hype, and I can answer very quickly. The answer is yes. The real question is, what is AI anyways? Besides being a horribly overused buzzword at this point, thank you to our IBM friends for some of the marketing in that space, but the real key is how can we define and derive value from all of those things that are considered AI technology. So the journey, if you will, that I'm going to take you on today is a tale of new oil and new electricity. If you've ever heard folks say, oh, data's the new oil and AI is the new electricity, what the heck do they actually mean when they say that? So we're going to talk real quick, what is AI? And then I'm going to make the case that it's absolutely hype. These are out of order from my fault. Then that it's actually real. And then we're going to talk about how there's gold in them nar hills and where companies are really finding value from using these technologies. Real quick, first, my name is Brian Martin. I'm the Cognitive Architecture Lead for Publicis.Sapient. Cognitive, again, another IBM buzzword, thank you. What we do is a lot of things across a lot of spaces, both from a standard consulting, technology consulting perspective, but generally with a strong focus in marketing and analytics. So there are 3 or 4 real large companies in the world that manage and do advertising. And those 3 or 4 big companies create 98% of everything that you see in digital advertising. And so when you think about the data from that perspective, these companies have massive amounts of behavioral data on consumers. Think about how Facebook has billions of customers. Imagine what the cookie and click-through streams from these companies' advertising is as a data set. So it's important to think about how AI has essentially become part of that space of business. I actually came from a small liberal arts school in Michigan called Alma College. I built the first Saturn car company website from my dorm room when I was a sophomore. I designed the first configure your own car thing on a website my junior year from the same dorm room. And then afterwards, I found my way through a bunch of other spaces into the financial industry and spent about a decade working in proprietary trading and global markets type work. So coming to AI was a roundabout course, as I was going to build airplanes when I went to school and then rapidly realized that computers were more my thing. And so studying computers and cognitive science in my undergraduate, I got to experience the second AI winter, as we call it, firsthand, because none of what I had really studied in the cognitive science degree we could actually apply until, a couple of years ago. So let's start real quick. What is AI? If intelligence is the ability to acquire and apply skills and knowledge, then artificial intelligence is the ability to artificially do the same. And we like to think about AI technologies as falling in two separate camps, soft AI and hard AI. And so soft AI is all of those technologies and concepts that help us bridge the gap from human to computer. So vision recognition, language processing, everything that's called cognitive falls in that space, soft AI. Hard AI is your deep learning and machine learning. That's the analytics heart. And you need both of these things. It's sort of a yin-yang thing. You can't have one without the other. You need the deep learning capabilities to do the vision processing. But without being able to perceive and ingest data from the outside world, you won't have that data for the analytics to be able to function on. And so the two pieces naturally fit together to be able to create this chain of acquisition and application. And I think what you'll find is that almost all of the modern technologies that are pushing boundaries, cloud computing, IoT, blockchain, they all come to play because they all help facilitate this acquisition and application cycle and how we use that. A quick history lesson. AI, most people go back to 1956, that big black and white picture from the Dartmouth conference. But in fact, we have to go back about 800 and some odd years to find the first sort of conceptualization of this. Ismail al-Jazari, in the year 1206, published one of the absolute base works on things about technology. He's actually credited with developing a water-based hydraulic automaton floating system that floated in a pool outside of a palace and using water played music while floating around this pond. And the music it played was programmable through a system of pegs. That was over 800 years ago. And so how much further are we actually beyond that if you stop and think about it? Not much further in many ways. And even if you skip forward from him 300 some odd years to Rabbi Lowe and the concept of the golem in Jewish history, right? In that concept, Rabbi puts the word called the Shem in the mouth of a clay statue, and the statue comes to life with a purpose. Well, what are we doing with AI? We're putting words in the form of a programming language into the mouth of this metal beast, these silicon robots and these things, and making them do things. But the interesting thing is the tale of hubris that comes out of Rabbi Lowe and out of that mythology, that if you aren't careful what you put into the mouth of that robot, you will reap the rewards or the non-rewards of doing that. And so there's an important lesson from over 500 years ago, almost 500 years ago, that we need to take in mind as we start to embrace these technologies. Alan Turing, 1936, 1950, what can we say except for the Turing test laid a lot of the groundwork for the 50s discussion of the Dartmouth Conference. And then in 1974, you have Paul Werbos, who conceives of backpropagation. And 1986, obviously most people who are doing work in this space, Geoffrey Hinton, who actually implemented backpropagation in technology. And then we scoot forward to 2015, and people argue that this is actually, that AlphaGo and AlphaGo Zero are actually the greatest example of how we have evolved this technology to be human capable. And I think that's what leads us into the hype discussion. Because if the absolute greatest example that we have of an ability for a robot to be going beyond human capability is playing a game with black and white stones on a board, then we're not going to be drastically affected anytime soon. And that leads us to, it's all hype, right? The fact is it's been hype twice before. In the early stages, the first AI boom was driven, this concept of GoFi, or good old-fashioned AI. It was driven purely by imagination and theory, right? What if we could? And no idea. And so all the theories that come from that time are based on these just pure conceptual, what if we could replicate human beings? What if we could replicate what humans could do? And then the realization is that the technology just did not exist for us to do that. And so all of that hype falls away after the Dartmouth conference. Second AI boom, now we have computers. We can put PCs on every desk. Computers are going from room size to desk size to fitting in your watch, to fitting just microization of that. And so that led a new boom with expert systems. What if we could say, if this, then this, and a computer can do it? And what we realized was the challenges of scaling that expert systems decision-making process were so huge. How do you codify every single rule that a human does when they make a decision, when they go through that process of even deciding whether to click to the next slide or back? Am I ready in the presentation to do it? And so the realization of the absolute inscalability of that is what kind of caused the second AI winter. And the third boom is being driven by machine learning's real ability to allow us to scale that at speed across data that is an immense quantity. When you think about how much data the human brain processes, it's phenomenal. And now we have the ability to come close to that, in some ways, with computational power. And so suddenly we have this new boom of this machine learning-driven approach. The fact is, though, that winter is coming. Again, we are going to see another AI winter. I will state that on the record. I am absolutely 100% in belief that we will. There are a lot of reasons for that. First off, the tribes of machine learning, there are 5 of them. If you've ever read Pedro Domingo's book, The Master Algorithm, he explains it very well, what those 5 tribes do to be able to work together. There's a lot of other reasons here about why it's not yet coming, but the biggest thing is just we're not ready. Real. So there's this thing called the Virtuous Cycle. It ties together tools, people, and data, and 3 different kinds of value: operational value, experiential value, and analytical value. This is what's driving the progress of deep learning in this space, is how AI allows us to accelerate and generate momentum within this. Operationally, data-driven automation, robotics, the ability to actually engage in business processes in an automated way, it's providing that scalability and personalization of the experience. Marketing will no longer be, I create an ad to target 20,000 people. It will be, I create an ad to target 1 person. And when I learn about you, I target you specifically. That's the future of advertising and marketing, is not seeing ads that everyone else is seeing, it's seeing ads that are meant for you. Experiential, when we get that type of advertising and marketing capability, we also have other experiences that can be created. Think about Amazon Go, the store where you walk in, take your stuff, and walk out. How could we even conceive of that kind of experience without some artificial intelligence capabilities? And then analytics. Analytics is driving this all through. Google buys Nest, a thermostat company. Why? Why would Google buy a thermostat company? Because the data they got from consumer usage of their cooling and air conditioning and heating allowed them to turn around and 3 months later create a report that they sell to every single electricity generation company in the United States on a monthly basis. Immediately monthly revenue stream. And gives those companies the ability to actually, without you even knowing, turn your thermostat down by ½ degree because the display doesn't show decimal temperature. So if you say 72, they can make it 71.5. And if you take that ½ degree change and apply that across hundreds of thousands of households, the impact is millions of dollars in electricity generation power. That's a capability that isn't delivered without analytics and data. We did a survey. This is, the maturity level of various different industries, and it's probably no surprise that tech and finance are the two most mature in the applications of some of this. The energy consolidation near that mid to low is kind of interesting as well. Energy and commodities, though, also has some leaders in that space, companies that have engaged very early. If we look at where that maturity is by the actual category of approach, their vision, their budget, the technology foundation, we see people have bigger eyes than they do appetites, right? And this is why we know another winter is coming, because people have grand visions, but they don't have all the backing to make it happen. There's gold in them Nar Hills. We mine value from the new oil. Data is the new Texas tea, and there's two ways to engage it. You either start with analytics, and you move clockwise around that cycle using the analytics to drive automation, to create new experiences, to get new data, which drives more, create your momentum. Or you go backwards. You start with automation. You get operational value from that. You use the data from that to say, okay, if I had new analytics, I could create more. And then if I had new experiences, I could create more data from that. And so you engage the cycle one of those two ways, usually depending on where you start. In the end, it's not the economy, stupid, per James Carville, it's the experience. In the end, user experience is what is going to drive this. If you create bad experiences, you will get bad data, you will create bad feedback loops. If you create positive experiences for users, you will get data that creates that feedback momentum you want, and it will drive your business forward. And so, what do? We act like Gretzky. We look to be where the puck is going to be, not where it already is. And so when we understand those feedback loops, our goal is to acquire skills to be able to manage and interpret all of this data. So acquire skills to design and build the tooling. And it's skills to understand people. There's a reason that you have data, technology, and user experience at the core of every single thing you're trying to do as a company today. Because without those three, you can't engage all three parts of the cycle. Focus on why you're solving a problem, not just how to solve it. The best line from Jurassic Park, Michael Crichton book, Ian Malcolm's line. They spent so much time figuring out if they could, they never stopped to think if they should. And that's where we are with AI right now. We need to stop, pause, and understand that the reason we're doing all this is for people. If we don't use this technology to provide people the experiences and value that they need, we're not doing anything worth doing. That's it for me. Thank you very much.
You've done a great presentation about the winter that's coming, but the summer is also behind it, right?
Summer is behind it. We've got, when you think about deep learning and what we've been able to do, it's a lot more than, is it fried chicken or a dog? Or it's a lot more than, dogs versus blueberry muffins. It's, driving personalized marketing. It's driving more efficient operations for companies. Penske. I mean, I can't even imagine if you think about how they're able to apply that to their cases.
Quick questions for Brian. Anybody in the audience?
Sure.
So another big word, a buzzword is personalized medicine. Sorry, another big buzzword is out there is personalized medicine.
Yep.
Do you think artificial intelligence paving the way to make sure these patients are treated well? Can they predict their diseases which they're going to have and so on?
I think it's very early to be able to do that. I think there is a lot of low-hanging fruit that we forget. That improving patient outcomes via giving healthcare providers better decision-making data will help them to make better judgments and will help patients to make better judgments about their own care. So to me, although the focus on diagnostics, predicting cancer, things like that is interesting, we can use this now to help improve patient outcomes by helping doctors improve patient care, by helping patients improve what they do.
We take one more.
What do you think of Elon Musk's fear of AI as the doom of humanity?
So I think that the interesting thing is generalized artificial intelligence, or AGI, is far enough off that I'm not worried about it, because we will shoot ourselves in the foot much sooner than we can accomplish AGI. You think about what we're doing now with these specialized artificial intelligence capabilities, and then we're networking them together. Concepts of swarm intelligence are certainly much more frightening to me than some super intelligent, albeit Skynet kind of thing. The fact is all it would take is one bad weather prediction system tied to one bad traffic flow management system, tied to one bad, vehicle management system, and you're killing people in car accidents. So the idea that it's these connectedness of the special intelligence will allow us to shoot ourselves in the foot much sooner than the generalized intelligence that Elon Musk is talking about. That said, I absolutely believe that if we are not careful, we will shoot ourselves in the foot.
Very good question.
I think there's risk.
Thank you, Brian. Next is Amanda Yoho from IBM.
Hi, everyone. I wanted to thank the organizers for letting me be a part of this amazing workshop today, and giving me the opportunity to stand up here and talk with you about asking the right questions of your data. So I think this is a really good segue from the talk that Brian just gave, given some historical background and talking about the fact that we're serving people, and discussing what really goes into the artificial intelligence that we're speaking about today. So before I get into that, I wanted to give kind of a brief history of myself, at least going back to graduate school. So I obtained my PhD from the physics department here at Case Western just a few years ago. Thank you. My research was in theoretical cosmology, and I transitioned into the healthcare space right out of graduate school. So I started with a company called Explorus. It was a startup here that grew out of the Cleveland Clinic that helped hospitals do population health management. And I was a data scientist on their innovations team. That company was acquired to create IBM Watson Health in conjunction with a number of other startups. And I transitioned into team lead for life science innovations. So primarily focusing on data that's used for research and innovations by pharma companies, and even internally to support our own IBM products. And most recently, my role has transitioned into Director of Research Informatics across all of Watson Health, not just focusing on the Explorus data asset that we have. But we're not here to talk about me necessarily, we're here to talk about data and artificial intelligence, so I kind of wanted to give a perspective of what each one of those pieces of my career path meant in terms of data experience. So in my graduate studies, I looked at the cosmic microwave background, so that's light from 300,000 years after the Big Bang that we measure with satellites, that we can take in and do analytics on to lend weight to or show gaps in theoretical cosmology theories. At Explorus, I was working with patient-level health information, so individuals at healthcare systems providing some identification of risk of that patient to develop a certain disease, or helping providers find patients that they hadn't adequately screened for different risk factors. As I moved into the life science space, I was working with a de-identified data asset of over 55 million patients. And then in my recent role expanded that not just a clinical data asset, but claims paid financial information from things like your insurance providers. And we also have linked the two, so you have some kind of financial information with the clinical information, which is a really powerful tool for a lot of research applications. But enough about me specifically, let's talk about the topic at hand. So it seems like artificial intelligence is everywhere. It's used in astronomy and cosmology. It's used in imaging. So this is an example from deep sea research where they use it to detect features in images. It's used at my company for drug discovery, so can drugs be repurposed for certain uses? And this would be a good time to pause and say, I'm not here as a part of the IBM marketing machine. I'm speaking to you just as an experience, my experience with data and artificial intelligence. So I'm trying to keep this academic and not focused on my particular company. But a lot of my examples will come from the healthcare space. Artificial intelligence is used by Netflix to recommend a new program for you to watch. It's used by Facebook when they say, is this your friend that's in a photo with you? It's used everywhere. But what we're asking is it real or is it hype? And so in addition to all of these applications that it seems like you're hearing about everywhere, there are also some issues that crop up with leveraging this particular technology. So facial recognition was shown not to have the same accuracy across broad swaths of the population. There's been attempts to use artificial intelligence in hiring, but what they found is that they ended up replicating some of the biases that went into the hiring in the first place, even though humans had been removed from resume reviews. So what can we do about this? It's my perspective that real, meaningful artificial intelligence starts with the data that you have at hand. If you want to talk about real and not hype, you need to look at the data that you're feeding into these technologies that you're leveraging. There's an article that I really liked in the Harvard Business Review that says, if your data's bad, your machine learning tools are useless. And I completely agree. So let's talk about how do you avoid bad data? And I always ask myself these 3 questions when I'm assessing a data set before embarking on a project or helping others with their particular projects. And I want to mention this is not an exhaustive list. These are just the things that I find help me the most. So 1, where did my data come from? Who owns it, who collected it, and why? This is really, really important because it can give you some idea of what sorts of preparation you might need to go through in order to use that data in an appropriate way for your application. So in healthcare, health data lives in a ton of different places, at your insurance providers, in your wearables, your devices, things like your phone or your Fitbit. Pharma companies can have information on individual usage of certain medications, and obviously your hospitals, healthcare providers themselves capture your data in their electronic medical records. So let's talk for a minute about the 55 million patient clinical data asset that I'm used to using, which primarily comes from hospitals. Obviously the clinicians, doctors, nurses are the ones who collected the data. And why? So that they can care for you. They want to make sure that you're healthy. They want to make sure they're helping you manage certain diseases. They're not walking down the hallway to ask their colleague if they're using the same abbreviations for the same condition so that when those 2 data sets are merged together, you can unambiguously tell what means what. They know that they want to follow up with you in 6 months about something, so they say they've seen you in October of 2018. They don't perhaps care that another researcher might be doing a 30-day prediction model on that very disease, and so the date and time that they have seen you is very important to that particular research. All of this is to say the reason that the data was collected does not necessarily match the future use case of that kind of real-world data. And this is in opposition to something like a clinical trial, where data quality and analytics are at the forefront of the mind of the people who are collecting that data for a particular use case. So 2, was the data manipulated in any way? Was there standardization, curation, or normalized? Was it normalized? Are there outliers, unexpected values? Is there bias? And I think that bias is a big one in the facial recognition thing that we just talked about. The data that was fed in led it to having more accuracy on certain sets of the population because the data represented more of that subset of the population. So again, another example from my sphere, this is a representation of the distribution of the patients that are in that clinical data set that I mentioned already. And you'll notice there are some hotspots. We overrepresent the Midwest. There are a lot of patients from Texas, for example. So let's say you didn't have this map, you didn't take a look here, and you fed in the data to say, what are the biggest predictors of a certain disease state? An algorithm might reasonably output being from Ohio. So you don't want to develop that disease, move out of Ohio. Go to Arizona. But that's not necessarily a true feature of that disease. It's perhaps, and most likely, a feature of the bias that's inherent in the data. And so you need to make sure that you're taking care of those kinds of issues before really trying to interpret what's coming up. And 3, does the data have what I need? To what extent is there missing data? Is the sample size large enough to make any kind of real statistical statements? And missing data in particular, I think, is a big issue when it comes to artificial intelligence. And to that end, I have an example from a publication. This was published in conference proceedings for the American Medical Informatics Association, some work that I did with a number of colleagues that are listed here at the bottom. So I joined this collaboration after it had already started, and a colleague of mine came to me with a plot very similar to this, but not exactly the same, and said, hey, so we were predicting what are the chances you'll end up in the emergency department if you've been in the hospital in the next 30 days? We gave patient demographics, diagnoses, drug history, utilization, procedures, all sorts of things. Our population size was 3 million patients, and we had over 2,500 features. So this is the largest 30-day ED prediction model to date, and that's a very active area of research. So he said, hey, none of the procedures that we fed into the algorithm came up as important at all. Isn't that kind of strange? And I was like, yeah, that is really strange. So we sat down to kind of brainstorm what might be the reason for that. I said, oh, well, maybe, if you have a certain diagnosis, you're likely to also have a procedure or vice versa. And so maybe those two things are redundant. That's why we're seeing diagnoses. We're not really seeing procedures. I'm like, maybe, but probably not. It should show up somewhere, alongside those same diagnoses, or you don't always see the same procedures. So I said, okay, well, what about the data? How did you prepare the data that you fed in? And they said, well, we took ICD codes, which are International Classification of Diseases codes, and group them into meaningful categories. So instead of every specific disease or procedure, they said, we're just going to take all gastrointestinal issues, group them together, and use those as our features. And then that's what we're going to feed into our algorithm. I said, okay, so you did this both for diagnoses and procedures, correct? I said, yes. I'm like, that's the issue. That's exactly why it's not showing up. So if you look at the real-world data, when it's provided from the healthcare systems, diagnosis records will have an ICD code 95% of the time. So when you do this grouping, you have all of those diseases ready to go. Procedures, on the other hand, have an ICD code on them less than 10% of the time. So it wasn't an actual feature of the algorithm. It wasn't any sort of procedures don't predict this. It was just a fact that it was not represented in the data. It was missing. And so we had to go back, revise the initial question that we were asking, redo the analysis, re-prepare the data, start from scratch basically, and do that in a more appropriate way given what we knew about the data that we were feeding in to our algorithm. So what are the takeaways? Always question data origin, quality, and bias. And these things aren't unrelated. So if you have answers about what the origin is, it'll give you some indicator of the quality for your purpose. Like, for example, clinical trials versus real-world collected information. And real impactful artificial intelligence starts with a good understanding of your data. If you want to be able to apply, if you want to take action, if you want to have insights from artificial intelligence, you have to trust the data that goes into whatever algorithm or technology you're using. And I would caution, if anyone starts to talk with you about artificial intelligence, it's easy to get caught up in the exciting, let's talk about TensorFlow, let's talk about the technology, but take a step back and ask about the data first. And just as an aside, I'm going to sort of echo something that was at the end of the last talk, which is, as we get more into data science, artificial intelligence, we need to really be thinking about data use and data ethics. And so I would really urge everyone to consider, as you're applying these kinds of technologies, who does the model serve? Is it explainable or interpretable? Can you tell someone why the answer is coming out the other end? And what are the real-world implications of applying the model? Who is affected by taking action on those? And there's a book that I would recommend. Even just consider many of the points that are in it. It's Weapons of Math Destruction by Cathy O'Neill. She talks through a lot of the pitfalls that are easy to fall into if you don't consider a lot of these issues. And I will end with that.
Thank you. I really like Amanda's message of are we data ready? Otherwise, destruction is on the way. So quick questions for Amanda before we move on to the next piece. Any questions from the audience? No, good, very well, thank you. Next, we'll start our next.
Good morning. Now for something a little different. So hopefully this will answer the question of the gentleman on the aisle. I want to talk about healthcare in general. And one of the first things that you learn when you are becoming a doctor and taking care of patients is how to take a good history. Because taking the history is how you get to the diagnosis. Because a good history is getting to the story. It's going to give you the pertinent clues and the data about that patient and that person and that history and who they are that will help you get down to healing. And that story is what you're going to input into the electronic medical record. Because healthcare ultimately is about stories. So let me tell you my story. My story is a little bit different than some of the other stories you're hearing about up here. So my background is that I went to college and then I ran away and joined the circus. I studied at Ringling Brothers Barnum Bailey Clown College and became a circus clown. And then I studied improv at Second City. And then amazingly, I decided to become a doctor. So I am a graduate of CASE and the medical school. So yes, yay CASE. And so of course, my career as a doctor led me to the emergency department because where else can you join another circus and practice your improv skills other than the emergency department? So when I was in the emergency department, I was still really interested in stories and in patient stories. And so I got the opportunity to start the first Office of Patient Experience for the Metro Health System where I worked. And that was my opportunity to really delve deep and understand patient stories from throughout the system. Because running the Office of Patient Experience, you really get to hear every story about every experience in the system. So let's switch gears a little bit and talk about AI in healthcare. And you've heard a lot about the exciting things that are happening in AI in healthcare from the first two speakers already. But AI in healthcare is booming, although winter is coming. But right now it's booming. Accenture says it's going to be a $6.6 billion industry with 40% expected year-over-year growth. And it's going to save the healthcare industry possibly $150 billion a year. Unbelievable. And it's growing in lots of different areas. We just heard about how the EMR can help us with population health and identifying at-risk patients. It's incredible. Robotic surgery through AI, invasive surgery, minimally invasive using data from prior surgeries. We've got 24/7 virtual nursing assistants who are available to communicate with patients whenever they need it. We've got diagnostics, which we've already seen have pros and cons, but that's where things are heading. We've got, let me tell you, if any of you have children that are thinking of going into radiology, tell them to pick another career in medicine because we've got AI that can scan 1,000 images a second, and I don't think we're going to have a lot of radiologists in the future. So pick a different career. But even though this is some amazing things that are happening in healthcare, the bottom line is that AI can augment a physician's thought processes and their reasoning, and it can uncover hidden health markers that can't be manually observed. It can look at structured and unstructured data, at results, experiences from across systems to uncover trends. But what AI can't do, it doesn't have expertise, it doesn't have intuition, and it doesn't have human insights that people do. And ultimately, medicine is human beings caring for human beings. And in my experience in healthcare, what people want, patients, and what providers want is three things: more time, more information, and more support. So what can AI do? Well, first of all, as you asked and what Brian talked about, is we can empower patients to engage in their health care by supporting them with information and ways to participate. So for example, lots of people are using their portals. People are using digital tools. You know, we've all got our Fitbits and everything, and now we're sending information with the new watches. We're sending our healthcare data much more freely. We can team providers with intelligent guidance to provide personal information and help patients take the next best steps. And we can engage patients with insights that are personal and contextual. So in the same way that we're sending somebody targeted advertising, we can send them targeted health information. And so many people are asking about their own personalized DNA, who's my ancestors. That information can be used to give them information about healthcare. But it's risky because you're putting your information out there. But people also want it now. So let me ask you a question. Who here would go to a restaurant without looking up the review or without checking it out on Yelp or on OpenTable? Or who's going to buy a new refrigerator? Oh, you would? Yeah, I wouldn't. We're not going to dinner anytime soon. Who bought something on Amazon without reading the reviews? Nobody. And the bottom line is, in healthcare, this is becoming another truth. People are choosing their providers and their healthcare systems based on ratings and reviews. And this is influencing the whole healthcare system, and it's doing it actually in positive ways. On the user side, on the patient and patient family side, studies are showing that reviews actually matter more than the quality data that's posted about and available about doctors and about health systems. But on the provider side, and I can speak from personal experience having used these ratings and reviews to influence the physicians in the system that I worked in, this actually influences behavior in positive ways, and it influences systems to identify areas for process change. So let's talk about a typical patient journey. So we have narrative data available for the whole patient journey before, during, and after a clinical experience, whether you're inpatient or outpatient. We've got surveys, we've got social media comments, we've got commentary and data that we're pulling from during the visit. But unfortunately, a lot of this information is really limited. It's limited to experience indicators from, these are the kinds of things that we're looking at right now. So right now, because of what the government has asked us to look at and really what we're sort of focused on, we're looking at things like, how easy has it been to find places? How is your billing experience? How is the communication between you and your doctor? This is the narrative information that we've been using. And it's limited. It doesn't really get us the whole picture of what was your experience like with your healthcare system. But the good news is we have the ability, and we can use all of these new AI and data analytics and big machine learning to expand and look beyond the traditional sources, to use both structured and unstructured data to have a really complete picture of what is happening to our patients and understand where these issues are. So we've got all of this social media, we've got the government sites, we have all the commentary, but we can add in the EMR, the notes that the doctors are taking, all of the billing data, all of the financial information. And by integrating all of these together, we can really start to make informed decisions and set up KPIs and process improvement that will impact patients and families and providers to make things better, which is what we want. Better experiences, better healthcare systems, better use of our healthcare dollars. So it's interesting to me that a recent KPMG study on customer success illustrated not only the importance of pulling all of this customer data in, asking people, how was your experience? What did you think? And then taking all these insights and spreading them out and feeding this back. And I'm sure Sherry's going to talk about this from her marketing perspective. Everybody's asking you, how was your experience? Will you stay on the phone and rate this, rate how this operator took your phone call? But what they're finding is that people don't want to do it anymore. And my theory is that people don't want to do this, and we're starting to get less and less data about experience because people feel like nobody uses the information for any improvement, for any real reason. So we were like, why should I give you my information? Why should I bother telling you how my experience was? Because it's not going to make a difference. So what can we do with this information? Well, taking all of this, particularly unstructured data, the world's our oyster. And I actually think it's not hype, it's real. And real positive things can happen from sentiment analysis and using this unstructured data to make positive influence. So just at a baseline, and because I only have about a minute and a half left, from a business perspective, just selecting hot topics and looking to where people are talking about things and almost finding what the unknowns are. What don't you know? What comments your patients are saying? What things they're talking about, and trending those down to see, why do you have patient churn? What can you do to influence that churn? And then setting up the process improvement or the change to go back and see, have we made the difference? Are we spending our financial dollars in the right way? My expectation is most of you are in business analytics, you're in business school, you understand KPIs. I'm not going to harp on this. I think you can understand how knowing where the hotspots are in that customer journey will be able to influence the ultimate ROI and financial impact of your system. What I think you don't understand is that healthcare systems aren't doing this. This is a new idea, and the majority of hospitals and healthcare systems in this country don't know about this, they aren't using it, and they don't understand it. This is new, and we need to start doing it. Because ultimately, stories are where our information are. It's how we relate to each other. It's how we talk to each other. It's how we share our history. It's who we are. And healthcare is people talking to people about being cared for by other people. Thank you very much.
I think it's a great idea about bringing back to the experience, which is the heart of AI, and our stories. So questions for Sarah?
Oh. So years ago, Walter...
Yeah, one second, there's a mic on. Okay.
Thank you. Some years ago, Walter Cronkite, who was one of the most renowned and famous journalists in the history of the United States, made the statement, "Our healthcare system is neither healthy, caring, or a system." Do you believe that AI is helping to improve that? And certainly your last comment about systems leads us to believe that perhaps not.
I think that there's always the tension between the caring. I think the people in healthcare systems, the nurses, the physicians, the people in the clinical spaces, that is a caring environment. I think there is a huge amount of pressure as healthcare systems consolidate, and because it's such a financially unstable world, there's a constant tension between the administrative financial side and trying to remain viable and caring. So I think that these tools that AI is starting to bring in that can assist in individualizing and hopefully taking some of the administrative work away from the carers and allow them back into that space of the actual human interaction will make for a more caring health system. I think if you talked to most physicians and providers, what they want is more one-on-one time, more eye-to-eye contact, and less interacting with a computer, or less taking the time to have to do administrative work. And if we can use these tools to do that, and if we can use tools to save money and utilize for population health, so as an entire system and country, we can save money and make ourselves healthier and focus on wellness instead of sickness, I think that we're heading in the right direction.
One more question, Rob?
Hi, thank you for speaking today. My question is based on the point that you made about radiologist jobs being eliminated. And that makes me think that the more rudimentary analysis-related jobs will be the first to go, sort of eliminated. So can we do anything to manage that? Is there something we can do to control it, maybe? It seems unavoidable to me, so.
Well, I think there are other people on the panel who may be better suited to speak about this. I think the benefit in some of those elements is it's not that we won't need people to do certain higher level radiology tools. So there will be plenty of room for other specialties sort of associated with radiology. But a lot of radiology is sitting behind in a dark room in front of a screen and scanning images. But if we can bring those people out and have them interacting with patients in a different way or doing some other type of work, that just scanning isn't necessary. So I think other types of clinical work will come out instead. So.
Hi, Eric Relson with the MS MBA program. Just a one-word answer at the most. Do you envision a time when the physicians are looking at reviews on the patients?
So when the physicians are reviewing the patients, like?
No, when deciding whether to provide care, they're doing a review on the patient themselves.
No.
Good, thank you. Next is Andrew Konya.
Thank you. Cool. So I'm going to talk about using AI to move beyond what and get to why. Now, quick little context, meaning here's how much you should interpret what I say as you should take it wisely or non-wisely. I've spent about 12 years on software and algorithms, so I've done this since I left high school. I spent about 8 years doing statistical physics at Kent State in the Hungarian Academy of Science. That quickly led me into machine learning and AI, which I initially started applying to physics problems, but that expanded quickly to problems of biology and material science, and eventually to language and peacekeeping. About 4 years ago, I dropped out of grad school, started a business, which it turns out is a very different skill set than building AI, machine learning, or doing physics. And so I'm going to talk mostly about things that relate to business. So it's 4 years of data points, so take it for what it is. And I've recently got about 2 years of what I'll call bureaucracy, which is taking these things like AI and building knowledge systems and applying them to the United Nations, which is a world that moves very slow. So In business, you learn to move fast, fail fast, and be pragmatic. And in bureaucracy, you move slow, think slow, and really don't want to fail. I'm going to focus on the business stuff here. So this is my understanding of what it takes in business to be successful. It's just a summation over the quality of the decisions you make and the quality of your ability to execute those decisions. I'm going to totally ignore the execution part for another conversation and focus here on how you make quality decisions. Now, it turns out what goes into decisions that are made in a business context is a combination of human brains and increasingly something that is like data and maybe insights on that data. And this is relatively a new phenomenon that's just really starting to impact how people actually make decisions in a business world. And my understanding is it probably looks something like this, which is there's still a lot of human left in the mix. It's decreasing a little bit, but the impact and the input that's coming from data is exploding in ways that I think all of these people alluded to, and in ways that you need to be mindful of. So where we're at today is that we have all of these really great ways of gathering data. I learned this as we started building our company, and that's you have CRMs that are going to have your sales data, and that's going to tell you are our sales going up or down, or what's our sales cycle. And you'll have your DMP that's going to store your marketing data, and it's going to tell you how effective are these different marketing channels and how well are these different messages performing. And likewise, you'll have your HCRM that's going to have the same for employee data, and your CXP, which is going to have all your customer experience data. And all of this stuff is going to signal what is actually going on. But unfortunately, a lot of what's been missed as we've built this system is the why. And it turns out that the why is something fundamentally important. So ever since we've started our company, we're always looking for something that are causes. And it turns out that asking why does something happen is another way of asking what are the causal things behind it. So in this case, when I say why are my sales up 30%, the only thing that really matters is what is causing them to go up. Because at the end of the day, it's only when I change the causes do I actually cause anything to change in my business. So here's my understanding of getting to this so far. So I'll leave aside all of the problems that don't have to do with people. It's a whole different class of them, and focus here on the types of problems that have to do with understanding people. So for me, it broke down to this. Why can be found in how people behave, how they feel, and how they think. And if you think about maybe your significant other and you notice something has changed and you want to really know why, you're probably going to do something like one of these three things. You're either going to do an experiment, poke in some way and see how it reacts. You're going to observe, carefully watch what's going on and try and parse out what's happening. Or you're going to have a conversation with them and ask them what's going on. Now, it turns out this is useful for maybe your partner. It's really hard to do if you have 1 million customers. So the power that AI brings to this scenario is its ability to start bringing us closer to scale. So experiments we can now do at large scale because we can automate. I'll put an asterisk here because this isn't really AI mostly. It's just like plugging a bunch of systems together to make stuff work. Pattern matching, which is going to let us build observations we can understand from data that we maybe don't, and natural language understanding, which is going to allow us to get conversations to be big. And all of this means that we're going to take the understanding that we can get today from one person, and we're going to scale that to a huge number of people. So I'm going to take you through a few examples here. They'll be mostly overly pragmatic because I've actually never taken business classes. Sorry. I'll probably use words and phrases incorrectly, but hopefully what you'll get is something useful. So this first example is experiments at scale and automation, and this comes from the first 6 months that we took our initial product to market. Now, we knew that our product served market researchers, and we were like, hey, let's do an experiment. We're going to come up with every different value prop we can imagine. That's like a sentence. And we're going to spend weeks and weeks and weeks emailing every market researcher we can find. And we did that, and we found, awesome, this one value prop, it was qualitative market research at quantitative scale. It resonated more than others. We went, why? It turns out none of us had any ideas. Luckily, we had hired Jeff, and Jeff went, hey guys, so you're looking at the change in value prop, but you're probably missing something important. And it turns out Jeff had an MBA, so he knew what he was doing. And Jeff said, it probably is that while you're thinking of market researcher as like one type of person, there's a lot of different roles here. So really, we want to understand how it resonates across all of these wide variability of roles. Well, we're like, that's crazy. We're not going to spend a year emailing. And then he went, check this out. And what he did is he pulled up LinkedIn and he showed us that we could take all of these different targeted messages. We could target them at all of the different roles that we cared about. We could have it click through to a blank page because we didn't actually we didn't want to know if the people would buy us. We just want to know, would they click on this value prop? And it turns out one of those value props resonated with one of those target roles. And we learned that this combination of the value proposition and the target role is what really was the levers that we could pull to optimize our click-throughs. And this actually told us exactly who we would go to market, who we would target, and how we would message to them. So it turns out this was really useful. So the next example here is around pattern matching and inference at scale. Now, this is really going to be about observation, but observation, it turns out, is the easy part. It's inferring and matching patterns that's the really hard part. So just to give you a few cool examples that I'm not going to talk about, but that are worth knowing. So this is some research probably over the past year or so, various ways of pulling observational understanding from data. Two cases here are using videos to pull out what are people doing? So that's an important part of observing and behavior. One of these is using smartwatches to understand what different activities people are doing. And all of these likely ladder into things like the healthcare data and others. I'm not going to talk about that. I'm going to talk about something I think is actually much more powerful and pragmatic today. And that is doing data imputation using supervised learning. Now, you can store that word for a moment, and I'll explain what this means with an example. So let's say that so you can't see this so good. So let's say what you have is a data set, and you actually are pretty good at keeping your data. So you have, for each of your customers, you know their demographics, and you know their NPS score, which is like how much they would share your product with someone else. But turns out you do some analysis on that, and turns out none of those demographics actually cause any change in the NPS score. None of them explain it. And so now you need to understand, well, what's going on here? Well, maybe you have intuition that if you're a cable provider and has something maybe to do with TV, and so you want to understand what are these behaviors? Well, you can't just go ask all your customers. It turns out that's like really expensive. But maybe you have a data set that you can purchase, which is quite possible these days, that has different demographics, and for those demographics, it has maybe what sport they like and what music they like. Well, what this is going to let you do is say, I'm now going to build a model that is going to, based on this data, learn how to take demographics as input, output what those various behavioral observations are. Then I'm going to take that model and my other data set, and I'm going to use that to now predict or infer what are those various properties of the people whose data I do have. Now, sew these things together, and what you get is a data set that now lets you look at what those various things are, like the sport and the music preferences, and how do they correlate with this NPS score, which is something I care about. And maybe in that what you'll find is that it turns out this thing you associated, that they like watching NFL football, is the best predictor of this change in NPS. And this now becomes something that's useful enough to go, well, our NPS is going up or down because our NFL viewership is going up or down, thus we should take this action to focus more on that or adjust our product accordingly. So this is a very simple example, but that application of data imputation is the thing I've seen the most. So from my company to the UN to friends' companies and beyond, it's not nearly as cool, but it is way more pragmatic than anything else that I've seen so far. So the last thing I want to focus on, this is where I've spent maybe the past 5 or so years of my life, and that's around natural language understanding. And this was really unlocked by 2 key advancements. The first was understanding of words. Generally, people will refer to this as word embeddings. It means a way to turn a word into a vector and then use those vectors to compute with them. The really big step after that was saying, well, actually, sentences comprised of words mean more than the sum of their parts. So that's a separate problem, and that's been not solved, but progressing really quickly in the past year and a half. So this lets us now understand language. And this brings us closer to this problem of what I really want to do to understand why. If I'm being honest and my partner is not happy, I'm probably just going to talk to them, right? That's the most efficient way I can get to what's happening. But unfortunately, if you want to say, let's replace one of these people with an AI, the tech just isn't there yet. So it doesn't actually feel like human, and if you need to dive into a problem, it's not going to happen. But it turns out you can do this, which is you can actually put an AI in the middle so that you can have a human have live conversation with a huge group of people. So you scale the dialogue of conversation, but you now do it in a way where it's statistically significant. So let me give you a few quick examples of people doing this in the wild. So the first one is about cats. So this is, believe it or not, a Fortune 1000 company that sells kitty litter. And they had a very typical problem in the business world, which is our customers have started choosing a different brand over ours. Kind of classic. Now, they knew that their branding was sweet. They tested it and people loved it. They knew that their pricing was spot on. And so they knew that it had something to do with their product. They had no idea what. It's a simple product, right? So what they did is they found a cat litter expert, and they found a whole bunch of cat owners, and they had a 30-minute conversation between the cat litter expert and the cat litter owners. Not rocket science, but at the end of this conversation, they were able to understand that it was the difference in the consistency of the product, the weight of the product, I guess lugging it around, and odor control, which to me seems obvious, that were the things that best made people start switching to other brands whenever these things switched. And so this let them take this to their head of Cat Litter Innovation, true title. And now they put R&D efforts against each one of these product areas so that they can improve the product. So a lever to pull. Now, this last example here comes from a bank, Barclays, I didn't know of until I moved to New York a few years ago. And they had, again, what I think is a fairly typical problem. They noticed that when they measured all the productivity across their offices, one of those offices really sucked. Their productivity was substantially lower than everyone else. And if you talk to a person individually, they were smart people. And so they wanted to know what is going on here. So what they did is they first were like, well, we send out an engagement survey. Let's see what varies at that office versus others. Turns out nothing. They thought it was technology. They thought it was facility. None of those things actually told them what was going on. So there was this fellow, Brian, who had heard of this technology and said, hey, I'm just going to go talk to him. Turns out at a bank, doing things quickly like this maybe isn't the norm. So he was a bit of a maverick at the time, but he said, I'm just going to go talk to him. Give me a couple hundred of those employees, and I'm going to have a 30-minute conversation. And what Brian uncovered in this 30-minute conversation was awesome. So the first thing he learned is he dug in to find out people were saying our meetings are just so ineffective. So cause number one, meeting ineffectiveness. All right, well, I don't know how to improve that necessarily. Can I get to a more root cause? And as he continued the conversation, what he learned was that people actually weren't using meeting agendas. If you don't use those, you should. Turns out they're really important to productivity in a meeting. And once he knew that they were meeting agendas, he now was able to combine that with his knowledge of the system, which was, we have an onboarding course that all of our employees are supposed to do to learn how to create meeting agendas, and trace it back to understand that the person leading that office had missed giving people access to this as they onboarded them. So all of these people were onboarded without being able to have meeting agendas. And so a 30-minute conversation led them down to a specific root cause that they could enact change on and have huge lift in productivity and thus ROI in something that took 30 minutes. All right, and only capable because you have things like AI. So I want to leave you with this, which is that really what AI does is it lets us do what we already do, which is understand how people behave and feel and think, and it just lets us do all of those things at scale. And if we don't understand how to do it for one person, we aren't going to be able to scale it to 1 million. So you start there, and then you figure out how to do it for 2 and 10 and 100 and 1,000 people to create scale. And all of that at the end of the day brings us to why something is happening. And if we know why, then we know what business lever to pull to create change there. So this is where I'll almost end to say that thing I referred to is actually what our company does. So full disclosure, we build AI so you can talk to giant groups really quickly. And my team informed me I should show you some cool results from the real world. And we discussed this at dinner last night. So one of the problems that we had been tackling when you're trying to understand language is people make up a ton of words. So all the time we would get made up words, and I could say them to a friend. I could say, hey, let's go metrify this problem. And that's a made-up word, but you kind of get a sense of what it means. And so we wanted to know, can we teach our systems to do this as well? Turns out it's way harder than it sounds, but it's pretty good. So in this case, we can know that metrify means potentially to integrate, incorporate, develop, utilize, create, and transform. That yummy with a whole bunch of M's means like yum yum, Rice Krispies, hee hee hee, creamy dreamy, licky delish, dog slobber, sandwich. and fluffball, and that gorgeousy, which is a real one from our actual customer data, that it interprets that to mean gloriously, delightfully, entrancingly, charmingly, broodingly, captivatingly, and absorbingly. So this is just an example that AI is probably a little farther than you think it is, but probably not as far as the marketing and news will tell you that it is. So with that, I'll end.
I think I really like the shift from what to why, but the linguistics are great, don't you think? Questions for Andrew?
When you scale up these conversations, you have one person having a conversation with hundreds of others. That part is not automated. That's an actual conversation.
So actually, and this probably is a broader theme that at least I've noticed in AI, which is generally if you reframe it from saying, how do we replace a person's job, to how do we take a job a person's doing and like force multiply it, meaning let them just do it across a bunch of people, it's a better strategy. So in our case, we don't actually replace a human with like an AI that's going to moderate. We just allow a human moderator to moderate with 1,000 people simultaneously. So it's not automated. It's a human that after, so I ask a question, about a minute and a half later, we've collected the data, we analyze it, we go, here's the things that best represent that group of people in natural language, and it's now the human who's gonna go, maybe I should follow up with this other question I'm gonna ask. And it's the human's ability to follow up based on what they learn that lets them like trace down a causal tree in the course of a 30-minute conversation. And that's not something we've been able to automate yet. So that's a hard problem.
Good. Any other question? All right, thank you, Andrew. Next is Sherry Sanger.
Good morning.
Good morning.
It's a pleasure to be here with all of you. I'll start out just like the rest of my panel members, telling you a little bit about my story and background, which also involves Case Western a bit, but also involves Kent State, just like Andrew. So I'm currently the Senior Vice President of Marketing at Penske, which essentially means I work on all of the typical marketing activities, the building the sales tools, the advertising, the market research, and so on. But I also hold responsibility for our connected fleet activities, which is putting devices on vehicles so that we can monitor them and pull information off of them to build tools for our customers. And I also do all of our work around emerging technologies and looking at the market intelligence around the things that are changing our industry and might change a bit of how our company operates in the future. And so today's conversation is, I think, an interesting blend of those different perspectives that I've been a part of at Penske. So for those of you who aren't familiar with the organization, it's a transportation and logistics company. So anybody seen any yellow trucks running up and down the road? We hope you do. The funny thing is, after you've heard me speak, you'll probably notice more yellow trucks on the road. A lot of people say that somehow those things are, interestingly, people are blind to them until they start to notice them. And now you'll probably see them everywhere, at least that's my hope. But we're in the business of movement. We help people move things from here to there, from A to B. So we help consumers move their household belongings, but most of our work is in the B2B side. And so that's about 95% of our revenue comes from that part. So I'll talk a little bit about that. My undergrad experience was at Kent State. So locally, I majored in German because they told me to major in what I loved. And I liked language at the time. And so I went off and I became a translator after I finished school. I went to Germany. I spent, a couple of years in Germany while I was in school and spent a year in Germany after I graduated as a translator. And I found that translating documents in a cube all day wasn't that exciting, or it wasn't as glamorous as it seemed like it might be. There really weren't a lot of people to talk to, which was problematic for me. So I came back to Northeast Ohio. I'd actually grown up in Northeast Ohio, so also why I love being here today. I love coming back. But I came back and I was a translator here locally for a little while, and then I took the GMAT and ended up at Case Western in the MBA program. So I'm a proud MBA program grad. Thank you. And also a proud graduate of the PhD program from the management school. So Andrew, I don't know, you sounded really astute about business, I have to say, despite the fact you said you have no formal training, but there's this really crazy looking building one street over that you might want to check out and spend some time with us, because we would welcome that. So I also help out in the PhD program right now, helping out the first year students shape their research, and I really enjoy that. I love being in the academic world and having a foot there while I'm still in the world of practice. So my interest in AI comes from my functional area, from marketing, and some of the changes that we're seeing in marketing, some of the opportunities that we're seeing, some of the hype that Brian so aptly articulated that we're seeing in the world of marketing. We certainly see marketing for good, but we also see the creepy side of marketing, which I think you also indicated. I like to think we're more marketers for good at Penske, but we think about how do we provide exceptional value, experiences, and results. How do we provide good experiences for our customers is first and foremost what we do, and that's the side of AI that I'm very intrigued by and interested in, not the part that is tracking you like crazy and following you and so on. And I'll talk a little bit about some of the downside of that, but also the benefits of some of that for good marketing activity. And then from a business strategy standpoint, so I mentioned I also work on all of our innovation activities around emerging technology. So I've spent a lot of time over the last couple of years on autonomy, electric vehicles, fuel cells. More recently, we've been looking at a lot. So all these different technologies that are changing the shape of how transportation might happen in the future. And so I have an interest in AI from that perspective as well. And I'll talk a little bit about particularly what we've seen on the autonomy front. And I think you'll find that it follows a similar trajectory to what we've heard today. There's some really good things happening that improve safety, but there's also some things that are overhyped to the point of not being able to deliver right now. So when we think about AI, we think about it for good and we think about it sometimes not for good, like has been highlighted by our panel this morning. So we can think about WALL-E, who is this, highly emotive character in a movie. So we have two examples here from the movie production companies. And, this is an example of, AI being used for good, where WALL-E has this, incredibly emotive sense and engages people. But then we also have HAL from 2000 that ends up killing the crew that created him because he thought they were going to destroy him, right? So it's a little bit of a picture of the AI not for good. We've heard, I think, some examples about, some of the hype that's been created. And, when we listen to some of the quotes from some of the leadership at Google, they talk a lot about the possibility of AI and the possibility of particularly automating things that people can do very quickly. So if we can think of it in a second, the founder of Google Brain says, you should be able to automate it. The counter perspective, comes from some other leading thinkers. So the late Stephen Hawking thought this is really going to mark the decline in civilization for us. Elon Musk, who tends to be very pro-technology, I think somebody already mentioned his quote earlier today, right? Found this as a real risk, which is interesting because we see Elon pushing the envelope on a lot of things in the transportation industry. And then you've got McKinsey, citing job losses, which is the thing we hear about so much, right? The job losses that can come from automation and artificial intelligence. And it's a thing that causes great concern typically. When we think about, just bridging up what Andrew talked about with natural language, right? We use these kinds of things to try and find humans, actually, right? So this is what we use to try and block the robots that could, maybe get access to some of our information. We also use this actually to block robots from scanning all of our data. So one thing that companies do right now is they send robots out to scan down all the prices, that an organization uses. So our competitors do this to us, and we're constantly blocking it. And why do we care about it so much? It drives our costs up enormously in terms of the amount that we pay for search and so on. So there's very real conditions, that cause us to want to sometimes block the use of technology when it's used for, areas that aren't so proactive or good. And then there's also times when the reason we can block this is because the robots can't think in a distinctly human way, which has been highlighted by our panel already today, right? So they can't use the same kind of language that we would. They can't recognize all the things that we can, particularly when they're new and fresh, particularly when there's something that they haven't been programmed to understand. And so that's an important part of the perspective I bring to bear. And when we think about transportation, it's a challenge that we see all the time right now. A lot of times this technology is, touted as being able to do things that it just can't quite do yet. So that's just a very simplistic example. In terms of the possibility of AI, I titled my part of the panel to be about human imagination and the intersection of AI and human imagination and how distinctly important that is. And so the perspective that I bring is that AI can actually do wonderful things, and humans are what partially bring that to life. So some of my fellow panelists have highlighted this morning how important it is to know what you're actually trying to solve for and to have an important challenge that you're trying to solve for. But just trying to throw technology at a problem often doesn't yield great results, especially if you don't have the underlying data to really tackle what that problem is. Then you're just applying technology in a way that doesn't yield many results. So I believe that it's the imagination that humans bring that is shaping some of the best applications of AI right now. And, when you put those two together, the humans and the machines, that's where we're going to see some real progress and where we can automate some things that you might not want to do anymore. There are a lot of mundane activities that people do, particularly in the business world, in our world, things that are very manual, things that take people's time away from using their imaginations and thinking strategically or spending time with customers. And so we're excited about the possibility of freeing up people to do some of those things that only they can do and that can actually add more value for our business. So we're in this environment where the two together can be a greater than the sum of its parts. So in the marketing arena, the marketing world has long touted themselves as creatives, right? Over the past 10 years or so, we've seen the importance of analytics as well. And so marketing is no longer a realm, that's just held by these wild creative types, although we still have plenty of those. Think Mad Men or whatever examples might come to mind. But there's a lot of power in channeling both together. PricewaterhouseCoopers did a study recently where they talked to consumers, thousands of consumers, and they asked them about the possibilities of AI. And people felt like, wow, AI would certainly be able to write a song, might be able to write a book, might be able to write a film, but would they be able to write a Pulitzer Prize winning piece of work? Would they be able to write an Oscar-winning piece of work? And so that's the part that the creativity, the human imagination, the ability to sense and respond and bring emotion into things is very important. So marketing is certainly about the data, but it's always been about the human experience and being able to understand what our customers are going through. When I think about our consumers, right, who are moving their household belongings, that's a tough experience. Is it ever fun to move? No, right? We always need help. It's stressful. There's all kinds of things to consider. Understanding and unpacking all of that is a huge part of the role. Being able to observe what's going on, being able to help problem solve, those are important things. But in marketing, being able to target better, being able to find the people that we might be able to add value to, that's where AI can be very powerful. So I wanted to just share in my last couple of moments a bit of the framework that we use for thinking about some of these emerging technologies. And we've had to develop a framework to kind of think about these in a very formal way because there is so much hype out there. So I talked about autonomy. Last year in January, you would have thought we were going to see autonomous tractor trailers running down the world in about a week. Everybody was talking about it. Otto was running a famous beer run truck. Tesla made some announcements as well. All kinds of providers started talking about autonomy. This year, we've termed sort of the year of electric vehicles, and we're seeing a lot of hype around that. We're seeing a lot of energy around fuel cells, and we've been seeing steady progress around AI, certainly. But what we start with is, what is everything that's being said out there? What is the hype? And separating a bit of fact from fiction is a big part of the work we do. We start with a lot of the terminology and what people are talking about. We look at who the key players are, which in today's landscape is very different. A lot of startups in the spaces, along with your traditional players. We look at the driving forces for the different activity. And then we also look at what the challenges or headwinds are that these technologies might face. And then we look at the forecasts and projections, and we come to a sense of what we as a business believe is going to be, the timing on when we're going to see these things in our industry. When it comes to AI, the part that I subscribe to, I think is a bit of a blend of what we've heard on the panel. I feel like there is immense hype right now, but I also feel like there are some opportunities in specific areas. And as I described, particularly when there's human imagination that's put behind it. And interestingly, I think AI is sparking human imagination in such interesting ways, right? So AI is actually causing us to think differently about some of the problems that we've long held in different industries, including ours. And it's causing us to think a little differently about them. So it's actually spawning some really interesting imagination. And so that's the part that I find the most interesting about AI is the intersection and how it's channeling that. There are some people that believe right now, there have been some articles that have been written in the popular business press, the Forbes, Fortunes, et cetera, that are basically saying we're going to see more of a need for creativity and imagination and education in the future. You know, analytics and so on is going to continue to be important in understanding that, but being able to think creatively, being able to bring a design perspective and being able to observe and understand emotions is going to be an increasingly valued skill set. Obviously, that might be a little biased because I'm in marketing, but that's my perspective. So I'll conclude with a couple of thoughts on autonomy, which has been a fairly hot topic in our industry. You know, there are a number of players in this space, a lot of startups, which Otto was Uber's startup, which they actually have since shut down. And we also have all kinds of other players that are playing in this space. And what we found from some of the leading experts in this space, and we've had an opportunity to ride in the different vehicles. We've ridden in the autonomous Uber cars, the Uber truck on their test track. We've ridden in the Tesla vehicles and so on. And from a lot of the OEMs as well, we've seen their technology. And, you know, what I can share with you is, you know, the technology still isn't there to see like a human can see. And there is a very real challenge and need in this industry. We are in a shortage of drivers right now, truck drivers, believe it or not. And it turns out that there's more freight moving than ever. And so this is a real acute challenge for our industry right now, is we don't have enough people to drive the vehicles to get all the product to market and move the freight around. But what we're seeing is the technology isn't quite there to be able to see. So when you have snow, sleet, rain, bad weather conditions, the trucks can literally think that there's like a curtain hanging in front of the vehicle and they can't drive. If they encounter something like a pothole, they think there's no ground down below. You know, so there are all kinds of sensors and radar and so on these vehicles to sense them. But this is one of the toughest challenges that we have to solve for. So while there's promise of the idea of it, there's also a lot of very real technology challenges that we have to overcome and face to see that become a reality. So with that, I conclude my conversation. Thank you.
I think it's a great ending to the panel, the idea of imagination, how AI can facilitate that, grow that. I think it dives in where we started, the idea of the winter is coming and the summer behind it. So with that, I want to open up for questions from the audience. They can be directed to anybody.
My comment in general revolves around ethics. Sorry.
It's true.
All right. So, for example, in truck driving, there are often situations where a human being driving a vehicle will have to make a split-second decision that something comes up, that one or two bad scenarios can happen. Like you're driving a truck, somebody comes up behind you, and then a lady with a carriage goes out in front, and you have to stop, and the guy might hit you from behind. So if you leave this to AI, and instead of the human making decision, a software programmer has to program in what's going to happen, i.e. he can be sued because some judge says it should have been the other way. Those are the legal things which in the end may delay widespread implementation in the transportation industry of autonomous vehicles. It's the legal part, which can take 10 years behind. How do you make a legal decision without a precedent? You know, that's how our legal system works. These things don't go away.
You're hitting on one of the biggest challenges that everybody's facing and that everybody is very concerned about with these kind of vehicles. So, as I said, the technology is not quite there yet, but assuming that the technology reached that point, it needs to be programmed to make decisions that are sometimes really tough decisions. And to your point, they can't make the judgment call that a human can. So, when you think about a situation where a child is playing alongside of the road, we might scan and look at that and, make a judgment call on whether we need to stop. And we would know maybe, is the child going to potentially venture out into the road, or are they going to stay put, and so on. Those are judgment calls that a vehicle can't make right now. But even that decision, do I hit this or do I hit this if I have to hit something? That's one of the toughest challenges right now.
Yeah,
that's referred to as the trolley problem in sort of the classical literature about it. And the interesting thing is we've got a couple of points historically about precedent there, right? Mercedes-Benz came out and said, in our self-driving cars, our AI will universally preserve the integrity of the vehicle. Right? That was their statement. They said in any situation where the self-driving vehicle has to make a decision, be careful about decision versus judgment, it will make a decision to preserve the integrity of the vehicle above all other considerations. And the interesting thing is, what does that say about the judgment of Mercedes to build that into the vehicle in that way? And the key difference there is judgment versus decision. Those are two fundamentally different things. AI will never make judgments. It will make decisions. The judgment exists in the person who's programmed or the people who have programmed the AI to do that. That's sort of the fundamental key, I think, from that space.
Very well said.
Sorry, I want to add on, because I think you bring up sort of a bigger underlying issue around the ethics of some of this. And I think that there will ultimately be so many, there's always sort of secondary consequences or unintended consequences to technology and data that we can't know what they will be. And I want to give you a really specific example. So and this kind of goes back to radiology, but there is a health system that requires as part of their insurance policy, all of their physicians, everyone to wear a Fitbit, a Fitbit type watch that monitors their sleep habits, their walking, all of that information. And I was having a conversation with a provider who was concerned because he'd had a couple nights of not sleeping well. And he said to me, well, what happens if I go in tomorrow, and he happens to be a radiologist, and I miss something? Can this information that is being tracked be used in court? Because I missed something, and can they put the fact that I didn't sleep well last night? And so we are collecting huge amounts of data about ourselves, which can be used for positive and wonderful reasons to benefit our health, to benefit society in large quantities. But there are also ethical issues behind having all this data, and who owns it. What if that accident happened? Who gets sued? Is it the programmer? Is it the company? So I think, maybe the radiologists of the future should become lawyers. I think that's the bottom line.
I just want to add one more thing. One of the things that we've given some thought to is, maybe not going to those full possible levels. So just because we can doesn't mean we should in some cases. So we've looked at, using partial levels of autonomy, partial levels of intelligence right now, because what we know is there's a gradation that the SAEs put out on levels of autonomy 1 through 5, 5 being, completely hands-off, et cetera, that you don't even need a driver in the vehicle, and 1 being, fully hands-on. And there's an area around level 3 that is very dangerous because humans start to feel like they can take their hands off, but they really should not. And so there's a lot of companies saying, we're either comfortable at level 2, where there are advanced safety features essentially, or fuller levels. But there's these sort of dangerous in-between areas that we have to really be cautious about.
Quick note on two things. So you mentioned the legal implications and ethics and judgment calls in autonomy. Two things to be aware of. One is on the ethics and judgment call in autonomous cars. There's actually a project at MIT that's addressing this specifically. And what they're doing is basically iterating through all of the possible trolley situations, meaning tough ethical choices that you have to make in a scenario of driving, crowdsourcing humanity's belief on what decisions should be made there, and then making that data set publicly available to those building self-driving vehicles so that basically their ethics reflect our ethics. And that's kind of as good as they can do. The second around legal is that if you look outside of the United States, in countries where kind of the willingness to sue is much lower, then you actually see that adoption of self-driving anything and autonomy is outpacing us significantly. And so in so much as if that brings high economic efficiency, then that means it's hurtful to us to kind of move slow, especially given most studies that look at what the amount of times a self-driving car or truck crashes is actually an irrelevant number. The only number that's relevant is how frequently it would crash relative to how much we do. And that's what signals what the right ethical decision to make there is. And that's a conversation that people don't have. And if you do, it generally leads to maybe it's actually safer already, even though we know it fails at a lower frequency than we would. So,
yeah, I was exactly going to bring up that point. Is a lot of times out of these conversations, we see that one scary moment that happens because it's the big, splashy situation that nobody wants to have happen. But if we take a step back and we don't think about, self-driving cars having accidents and maybe something that's a little bit easier to kind of think through many steps of the process, the fact is a lot of times these things do better than humans do. And so we're outright decreasing the rate of a lot of these accidents. We might be saving lives, and you hear about, the cases where we don't. But that still brings up, it's a very good point and something that we all have to deal with is adoption in healthcare space. There's no doctor that wants a black box artificial intelligence, just tell me if this patient is at risk or not. They want to know why. They want to know, because they want to be able to say, yes, I trust this. Yes, I'm going to move forward with this kind of thing. So you have to kind of balance both of those things, the gains you can make in leveraging artificial intelligence with the real human innate need to kind of have control and explain.
At the back.
Yeah, you guys have been just great, by the way. I'm turning my question towards, as you look at your labor force and seeing people come into your operations you work with, is there anything you suggest to the educational community that would help guide them as to what kind of person you want coming into your organization, or other things that would help from I'm sorry I'm struggling with this question, but help bring better people into your organization? Are there places that they're lacking that would help as you go into that, they come into your organizations? Does that make sense at all? Sorry.
Yeah, I can make it quick. So I'll just context here. So we've grown from maybe 1 person to 50 over 4 years. So I've got 53 data points, and the 3 are the bad ones. But so basically, we've learned the things that really matter are, one, do they learn how to learn? Because whatever the environment is, it's not the same in 2 years as it is now. And the second is a bias towards pragmatism. I've learned a lot of people who come to us with like really good educations, they care about a lot about the details and about the how, but they care much less or focus much less on what gets accomplished and on what timeline. So I think that combination of learning how to learn and pragmatism is something that often gets overlooked in an education setting because we focus on what did you learn, and that is important. That's like your starting point, but your rate of learning, the better you can get that high for each student, the more valuable they'll quickly become as they integrate. And pragmatism just seems lost in education settings often.
I originally went to college to build airplanes. Theoretical cosmology, circus performance. I mean, I think that what you're seeing, a lot of the value, right? A lot of the value is coming from the outside ideas. And biased, because I came from it, I think that liberal arts education is absolutely a driver of success in this. Because the technology itself is whatever. We need to do it, sure. But the application of it across industries to that space, you need historians who can go to the UN and apply these kinds of concepts over history, over political science, in finance, in healthcare, in all those spaces. So to me, it's embracing that, okay, you're in a program studying neural networks and machine learning. You're going to take an art history course,
Yeah.
or you're going to take a music class, or you're going to go and sit with doctors in a medical class. Like having that broadening of experience to know how to apply it. That's critical to me.
Yeah.
So the book that I recommended also speaks to education and artificial intelligence that's used in education. And from that perspective, it's the way that teachers are rated and how they're doing and how they're performing given their students' performance. And one of the biggest challenges, I think, to education from that kind of perspective and application of artificial intelligence is, again, the data. Because so much of the data about our educational system has those biases encoded in them. Yeah. So I think one of the biggest advances we could make if we're talking not so much about what's the education background you need to get into artificial intelligence, but application of artificial intelligence to education, is to really take a look at what we're using to apply those skill sets. To my knowledge, the data that's fed into what helps predict a person being good at this job or that job or whatnot does not include things like the liberal arts education. It's more, what were your test scores? And so I think we need to take a look at what we're valuing there.
Okay.
Yeah, I would just add, I think sometimes your functional expertise gets you in the door, but it's your thinking. And as a fellow liberal arts undergrad, I wholly agree. My market research leader is a Chinese major undergrad. Another market researcher is a sociology undergrad. Right? So it's the thinking that they bring that matters so much. And then the other thing I'd say is those softer skills too, the collaborative people skills, the ability to interact with others, the ability to read a room and understand dynamics is huge.
I could probably add a little bit to say that in our program, we also believe in this partnership with the industry, because I think brings diversity to our classroom. New applications, new ideas, and many of the companies have been working for many years with us to develop content in the classroom. And I think broadening that scope is really our intention to make that happen at Weatherhead. And I know the question in the back there.
Hi. Regarding the healthcare industry, what effect, if any, has HIPAA had regarding your ability to actually gather data and use data?
Sure. So we do make sure that all of our solutions are fully HIPAA compliant. We make sure that we're not sharing data in ways that we shouldn't. We make sure that we're not storing data in places that we shouldn't. We make sure that even the individuals that provide us data, that someone who isn't allowed to see that data at their own organization aren't allowed to see that. So we take great care in making sure that we keep everything safe and under all of the appropriate regulations. And I think that that's a really important point. So maybe to abstract a little bit from HIPAA, but around data privacy and security and protections, in the age of artificial intelligence, what has been shocking to me, especially dealing with sensitive information like health data, is the entitlement people feel to the data sets. They think, I want to do this algorithm. I want to write this cool, I want to build this cool model. I want to use this really interesting artificial intelligence technology. So give me the data. Like, okay, but this is real patient. These are real patient lives. Even if you don't know the names or anything like that, it's still real information that's very personal to someone. But people say, well, I need it to run my algorithm.
That could save the world.
Yeah, exactly. So another reason that I bring up things like data ethics is exactly for this type of reason. And in addition to, should you ask the question from an application standpoint, you also have to think about how are you leveraging the data that you have, or what data is out there? Are you really entitled to have it? Is an appropriate use of what you have there? And so that's something that in my role now we consider and take very seriously.
Yes, I give a quick secondary data point on this. So I'm not involved in healthcare at all. It scares the crap out of me to touch that data. But I advised a company a couple of years ago now, maybe 2.5, and they ran up against some of the opposite side. So kind of the TLDR of what they took away from the experiences, so basically what they did is they looked at mammograms, and their hypothesis was they could bring the overall cost of identifying breast cancer down from, I think in the US at the time, I'm kind of making up numbers, these are order of magnitude, right? Maybe 10K or so. And their hypothesis, they looked at where was all the cost at. Turns out almost all of the cost is in the radiology and kind of like the services wrappers. But at the end of the day, like the right picture and the right algorithm theoretically could get you it. And they ran up against exactly the problem you mentioned, which is there's a lot of regulation around this in the United States. So much so that a small startup that isn't like weaponized in security and has an infrastructure of a large company around them makes it really, really, really hard. So they couldn't do it. But what they were able to do, pragmatic, scrappy young startup people, they said, okay, we can't have this. I bet we could do it somewhere that's not regulated. And so what they did is they went, I believe it was to Africa and in parts of Asia, and there they were able to get all of the data very quickly, and they were able to build this, and they were able to get screenings down to about $100 per. And this never made it to the United States. They actually tried to bring it to the US, and they could not get over certain regulatory hurdles, and I think certain, like, they called them emotional hurdles. I don't know what that means. And they actually they gave their technology away to those countries. They kind of installed it. They dissolved the company, and they were radiologists, and now they're back doing radiology for the time being while they can still make a lot of money. So I think it's a two-edged sword that begs really tough ethical questions above my pay grade. Like, okay, if you can bring the cost down and that saves 500 lives a year, is that worth the potential risk of exposing 7,000 records on average per year to the public? I don't know. That's a hard choice to make. So that's why this is a quick plug for, it's actually real important who we put in government these days, because that is the lever that's going to control a lot of this. And they have to make really hard ethical decisions that are tough. And right or wrong means a matter of lives.
Well, and there's an interesting aspect of that. If you do a study on a reduced population like that, can you even transfer that model over to the US, right? Can you even bring that model and have the same effectiveness? You've got a different environment. You've got a different cultural base. Does it even apply? And the other side of that is that if you think HIPAA is bad, wait till GDPR style regulation gets to the US. Because in Europe, the new GDPR regulations make HIPAA look like a walk in the park, especially when it comes to AI. The idea, two key tenets of HIPAA are the right to be forgotten. So if I build a model trained on your data and you say, forget me, I have to take your data out and retrain my model in that way. So in GDPR-based, our country is under GDPR. And the other side is the explainability. If you build a model in a GDPR country and that model informs a decision-making process, and somebody sues you and says, you made an unfair decision or an unjust decision, you have to explain why that model made that decision. And if the why is thousands of matrices of floating point numbers, and you say, oh, well, because these numbers say it, so that's not going to fly in a court. So, and the implications of failing in a GDPR lawsuit can be financially disastrous. So,
can you talk a little bit about the GDPR shadow on the US? How will it affect here?
And the interesting thing is we don't know yet what the impact is going to be. We know that all of our current agreements with the EU mean that we have to extend EU protections to EU citizens in America. So if you are an American company that also does business in the EU, and an EU citizen comes to the US, even if you capture that data, they still have the right to request to be forgotten or to challenge an international court under EU's regulations, those decisions. So are we going to see companies completely separate operations in GDPR countries from non, and never the twain shall meet sort of thing? It's a frightening and fascinating space when you start thinking about the implications. And in the end, the tension, right, is customer privacy rights. We know we want the rights to our data, to the rights to use our data and protect our data, and yet at the same time, we want the experience. Do we really want Netflix tracking what movies we watch, but we want to make sure that the recommendations that we get are good? So how do we provide that tension between the value of the experience and the value of protection of our data? That's the challenge that any regulatory and anybody faces in this space.
So we're dealing with this in a real way right now. So we have probably 30 to 40% of our business is in Europe. And we have this conversational platform which gathers data on people. And it basically is, it's a very gray law, meaning it's not actually, specific enough that you go, here's how you implement it in technology. And so a lot of precedents aren't set. So kind of everybody's fearful. I know for us, we just basically said, okay, we won't touch anything in Europe that has to do with, we won't touch personal data. So to some degree, it probably drops our TAM a little bit. And it means that now American companies have an advantage because they're able to move a little bit faster because we can gather this type of data. And we've more universally, this has led us, so that's like 2 quarters back. As of this quarter, we basically have realized that we don't actually need person-level information to do what we're doing. And so largely the effect of GDPR has been actually changed how we operate for our companies in the United States, meaning that we just don't touch personal data. So in the market research world, there's actually this third-party organization that's starting to come together, I believe actually partnered with IBM, that stores identity on the blockchain and allows us to process a bunch of information with no identity attached to it, no PII, which is what GDPR governs. But if we need to do something with PII or someone else needs it, there's this kind of centerpiece that you can ping that will have that information. And IBM seems to be relatively good at navigating all that. And so people are going, let's just let them handle all that and own our portion of the data, but without any personal keys or information.
Question there?
Hello, my name is Esther. Thank you all for coming and speaking today. My question is for all the panelists. What are some of the visions that you have that may be grand in AI or that you are intrigued by today? Just talk a little bit about that.
The grand visions of AI.
Yeah, so I can give you 2. So one, I guess this harkens back to where our company came from, which is we started looking at peacekeeping and realizing that in most parts of the world, large countries of people don't have a representative voice. And the vision is that we can actually train a model good enough to have real-time conversation on behalf of a country's or a world's worth of people. That we think our hypothesis is, if you look at what represents the US right now, well, it's like we picked a person and we said, what they say represents us. And our hypothesis is we can develop a better approach to that, meaning we can give you an artificial agent that you can ask anything and talk about anything. And what it says is the most accurate representation as possible of the people that it is representing. So I think that's that's the grand vision that I'm obsessed with.
Question here, I think.
My name is Narisa. I want to thank you for all your presentation today. And since Brian talked about how AI started with imagination, and I think that's AI started with getting involved with our every individual since childhood time maybe, so I think literature and media press are reflection about or projection about people reflection and imaginations about all the AIs at that time, which is really interesting. And I just wonder, as a professional, what's your insight about these literatures, the Black Mirror series or Machine Ex Machina and all these stuff? Thank you.
Scary as all get out. I watched a Black Mirror episode with my wife, and about 20 minutes in, she's like, "No, we're not watching the rest of this. This is wrong." You know what? There's a reason that Hans Christian Andersen's fairy tales are what they are, right? They are actually lessons. If you read through what they are not nice bedtime stories, right? They're lessons meant to tell tales. And humanity is filled with a history of us telling lessons. And whether it's a lesson from a character in Jurassic Park, or it's a lesson from Hansel and Gretel in the woods, I think the interesting thing is what literature tells us about what we need to be careful of if we take the time to listen. If we take the time to learn the lessons of the past, of how we've applied technology, learn from Oppenheimer, learn from those folks about how changes in technology affect society. Could you imagine a non-nuclear world today? If Oppenheimer and the team had not done what they'd done, if nobody had pursued the concept of splitting the atom, where would we be today? And so I think it's interesting from the history is that path forward of where we look to be. We want to be where the puck is going to be. And if the puck is going to be our own demise, we want to skate somewhere else. I think that's what the literature can help us do.
Yeah, very interesting.
Yeah, so I think to some degree, literature represents what we're capable of imagining at that point in time. And if you want to understand kind of the history of a piece of technology, what literature gives you maybe is not just the expert's imagination of it, but pop culture's imagination of that particular thing. So if you imagine Star Wars in 30 years ago, imagining how we would talk over phones, it's different now, but not too far out, but it was what they were capable of imagining. So certainly I think what people are capable of imagining sets to some degree the boundary conditions on what will be invented in the next generation. Yeah, and so it becomes a bit of a self-fulfilling prophecy of sorts, where technology sets the first set of boundary conditions, the imagination sets the second set of boundary conditions, and what exists in between is what we actually do. And then we make that new technology, and that lets us push our imagination further, which expands those boundary conditions, and like that, we progress as a society.
I sort of take a different picture. I think sometimes looking more at literature than necessarily TV. I think the TV and Star Wars and Star Trek and Black Mirror can be a little limiting because of the medium. Whereas in literature, it sometimes can be more opening because the person who's reading it, and when you're reading science fiction or something that's projecting out to the future, it sparks somebody's imagination of the possibilities. And it's not so limiting because you're not subjected to somebody else's vision or visual of what's possible. And just to give you a really specific example that struck me, I'm sure many of you are familiar with Ender's Game, the book. Yes. So I read Ender's Game as an adult not that long ago, but before the movie came out, and I'm reading it, and then I thought, well, this has to be relatively recently written because they're talking about blogs and they're talking about things like iPads and all of these concepts that are current. That book was written a long time ago, a long time ago, and I thought, wow, look at what this person imagined, and probably, I can promise you, people did not imagine blogging and tweeting and all of the things that are in this book. And I don't think that anybody projected some of the positives and negatives that came out of that, but it's just sort of beautiful what comes out of the imagination in literature and poetry and all of these things that then we grow from and develop. And yes, it can show us where we should be frightened, but it also shows us that our imagination is open to
anything, yeah.
To anything.
Isn't that a wonderful place to finish this panel? I think we begin with AI, and it's all about imagination. Let's give them a big hand.